Let's talk about capacitors, but in AC circuits. A quick revision about capacitors is that when you plug it into a DC circuit, it begins to charge and there is a buildup of negative charge on one plate and positive charge on the other. Initially, in the first time that you charge your DC circuit, your current is at maximum and it decreases over time. Your voltage, however, is the opposite. It's at minimum initially and it increases over time. So you can imagine that there's an opposite relationship between current and voltage. And an interesting thing happens when you put a capacitor in an AC circuit. Here's the representation of the relationship with a phasor diagram. It shows that the current of the capacitor is on the y-axis direction, while the voltage is on the x. And there's a 90-degree relationship between them, and this is important. So let's plot this relationship. I plot the voltage with the red line. I plot the current in a blue line. And you're going to notice that they are not in sync. They're out of phase with each other by 90 degrees. Specifically, the current, the blue one, is actually leading the red, the voltage. The voltage and the current are out of phase by 90 degrees. So looking at this diagram here, when the current is at a maximum value peak here, the voltage should be at 0. Would you look at that? It is. The important note to take about capacitors in AC is that the current leads by 90 degrees. A lot of future principles are going to be based on this fact. Happy capaciting!